Good Sports helps these communities and sports programs survive is by leveraging the sports industry and corporates within that industry, for example, Nike, Reebok, and other corporates to secure funding, such as Geico, Dr. Pepper, ESPN, and they also leverage the foundation community locally to take action and help kids get on the playground. Currently, they've managed to work with over 4,200 organizations, helping 5 million kids with $34 million worth of equipment. So Good Sports essentially works at a grassroots level with each school and makes sure that kids have the opportunity to play. So what we hope to do for Good Sports is, so having analyzed their data and their processes, we've seen that the majority of their problems are within inventory management and facility planning. So we hope to help them out with that in order to optimize the utilization of their existing resources. And these are three main problems that we're going to be targeting, which include protocols for inbound shipments, assignment of case or pallets, which is the storage methods, and categorization of inventory to have the facility laid out accordingly.
So Good Sports currently operates in a 20,000 square foot warehouse in Norwood, Massachusetts. The warehouse is divided into 9 zones, as you can see in the image on the right, with Zone 8 being designated for inbound and outbound shipments, and also kind of a multi-purpose room where a lot of staging and packing occurs. And they use 3 styles of storage, which are case racking, pallet racking, and floor stacking, which are usually identified depending on the donation type. And due to the random style of the donations, sometimes they receive items that are in low quantity or random support equipment, causing them to have a lot of mixed SKUs, which is also a problem that we're going to have to investigate. This here is our two images of case racking, and an example of items used in case racking are shoe boxes, as they are in smaller size and are more defined in their size. And these are usually located in zones 1, 3, and 4. Here we can observe pallet racking, which are bigger donation boxes and bigger items, which are mostly found also in zones 2 and 5. And this is floor stacking, which we mostly find in zones 6 and 7, where we also find most of the mixed SKUs.
So we have been provided the data of the inventory on hand and throughout 2016 onwards. So we have received around 10% of the cartons per pallet, and the rest we had to fill in manually, along with the cartons per pallet for the high volume stock keeping units. And this graphic is a representation about the units shipped and the inventory levels starting 2016 up to August 2018. And running the linear regression, we can see it is implied that there is a 10% growth. This is a snapshot of the data. So we have received the internal ID and the name, and then we had to categorize the items. We created the category, which is apparel, footwear, or hard goods, and then which sports it would belong to, and then it would identify the size using a formula, which searches keywords in the product names, which would be either adult or youth, and then the size, which is either numeric for shoe sizes or XL through small through X large for apparel. And we have also identified the major product types and the subcategories. For example, shoes usually are 12. Would be 12. The quantity per carton would be around 12. However, if they were cleats, they would be 6 or 8 quantity per carton. And then based on the product number and the quantity per carton, we would find the cartons per pallet required. and the total number of cartons required. And then we create the pivot table, which helps us identify the total numbers. We can also use the VLOOKUP function, which was not possible before, since the data was not organized. Additionally, it was a very manual process that took over 9 hours for our client. However, it is now automated, and using the function keywords search, we are able to automate.
So it's important to understand that we are the first capstone group to work with Good Sports itself and to understand the nature of the facility. Good Sports actually only has 3 staff in the whole facility dealing with those thousands of SKUs and products as mentioned by Hamid. What we have right now is the potential of Good Sports moving to a new facility, which is why they called us in. Right now, as Alon said, they have 20,000 square feet, which they're working on in their warehouse with the inventory they have. They need us in order to expand. So in terms of that, a variety of literature related to warehousing was available through scholarly databases. It outlined that there are 2 main issues faced by warehouse managers, which were applicable to the nature of our project as well. One being related to our project, the refurbishment of an existing warehouse, which is optimal. This includes aspects such as receiving, storage, order picking, and shipping, all of which are applicable to the context of our distribution facility. Secondly, another major issue faced by warehouse managers is implementing the correct inventory management and storage systems and policies, which we'll go into further in the next slide. This covers concepts such as order picking, size, and layout, more to do with the data that we have available to us today, as mentioned by Hamid. The 2 articles that we covered these 2 topics and issues faced by warehouse managers as shown is warehouse design optimization and improving productivity of manual picking and multi-rack distribution warehouses through the implementation of class-based storage, which is very relatable to the context of our project. As I said, there were 3 people. We have a manual picking process and multiple rack levels. Given the solutions that were implemented in both the design issue and the inventory management issue, we're able to relate some of those solutions in the context of our problem. One would be what Hamid mentioned earlier, an analysis of what we have right now, the data. Forecasting methods which incorporate trends, seasonality, and understanding which products have higher turns, which have lower turns, and what products are staying actually inside the facility compared to moving out. This will also provide us with the capacity of what Good Sports wants us to look into its time frame, which is 5 years. They want us to forecast in a 5-year period so they can get a good understanding of what their facility will look like. On the other hand, the inventory management issues, possible solutions that relate to the context of our project include inventory class ABC classification, which is simply classifying inventory as class A would be the highest demand turn in the facility compared to class Z, which would be the lowest. Furthermore, metrics from these studies, such as Q per order index, which stores a SKU based on how frequently it is picked per stock space required, and an EIQ analysis can be incorporated into the major batch study to both generate metrics and also solutions for an optimal facility.
Going forward, possible constraints that the capstone team will be facing would be, as Hamid mentioned earlier, possibly redundant data that we have in our on-hand inventory, as well as seeing that it is a nonprofit organization, they do have budget constraints that might limit them from being able to implement all the recommendations that we have. When it comes to actual recommendations, we would be looking into providing them with warehouse management system recommendations, such as potential barcode scanners and printers. We will also be looking into creating a tool to recognize the potential redundancy of data in the on-hand inventory locations. We will lastly be forming the forecasting model in order to determine the proper mix of storage styles to take into account the demand or the incoming donations that will be coming in over the next 5 years. And one last thing that we would want or hope to provide would be inbound and outbound protocol and inventory policies such as the ABC classification as well as the COI classification. Thank you.
Have you guys seen, like, in your literature, have you like seen examples from like Google and how they take random,
I'm sorry, which company?
like Google, that take random, like it's essentially random types and classify.
Yeah, so the second aspect of the literature review, the second issue, which was inventory management solutions, that did touch on that aspect of classifying and as well as what you
Yeah, my
said.
question was going to be like, what did you like find and how can you relate it to your program?
We found that right now, due to the randomness of donations from groups such as Nike, Adidas, their zoning is very random. As Alan was mentioning, you'll have 3 different styles that they have incoming shipments, and either they'll send a whole pallet, which consists of multiple cases. If they need to break down that pallet, they'll break it down, depending on demand from their or other organizations, or they'll store that entire pallet. Compared to organizations can also give simply cases. And if there's space in the facility right now, they'll put those cases, which will be grouped by category, on racks. If there's no space in the racks per category, it will on the floor. So to relate literature to that context, which I was talking about earlier, it's difficult to find a solution which implements, the perfect mix of case, floor, and pallet stacking. So we are just deriving solutions which are the most applicable to our case and to what we have available, which is the data, to implement the solution which will be more efficient.